Good evening. As we said that today we will discuss about the projectile motion. Okay. So, basically in projectile motion, okay, we will start by splitting the two words. What is a projectile and what is a motion? Have you seen the motion of a rocket? Huh? How that goes? Zoom. Huh? That's like something is projectile. Okay. So the first question that will be coming to your mind will definitely be what is projectile? Okay. What is projectile? Any object, okay, any object which is thrown at certain angle with the ground, okay, say some any angle theta. So if the object is thrown at certain angle with the ground, what will happen? The object will cover some horizontal distance as well as the vertical height at the same time. So that object is called as projectile, and the motion covered by it is the projectile motion. Now projectile motions, they are called by different names. They may be two-dimensional motions, or you can say motion in a plane. Now you will thinking that it's very difficult. Do not worry. Because this two-dimensional motion or this motion in a plane, or you can say projectile motion, they can be resolved, they can be solved, okay, in a very simple manner. How we do it? Okay, let me just show you. For this purpose, let me just first draw a simple diagram. Okay, so here we have a horizontal line, say, and from this point, let us just throw a basket. Okay, with some angle. Let us say this is there. Okay, so just throw the ball. Okay, so when you throw the ball, it will go. Okay, in this way. Say the angle is theta. So what will happen? It will cover some distance, horizontal distance, as well as some height. Now, with the influence of gravity, because of the influence of gravity, what will happen? Because of the influence of gravity, okay, initially it will move upward. Since you have thrown it with some velocity, it will try to move upward. But the gravity is constantly pulling it downward. So there will be a point up to which it will move, and after reaching that point, what will happen? There will be no further motion in upward direction. And because of the influence of the gravity, it will come downward. It will come downward. Okay. So this is the case with a projectile motion. Are you feeling bored? Okay, so you have to understand it. Okay, now let us say that you have given some u velocity, initial u velocity. Okay, so with this velocity, we have thrown the object is moving some horizontal as well as vertical distance. Now you must be thinking, why we are reading this? There are so many practical application of it. If you study the projectile motion, you can tell that to what distance a person is jumping. Means it can help you in the long jump estimation. Okay, yeah, it can help you while in a basketball throw, it can help you while kicking a football. You can decide that with what velocity you are kicking a ball and where it will land, how much time it will take. So we are basically dealing with all these things related to the projectile motion. Means in this motion, what we are going to discuss? We are going to discuss what is the maximum range an object can cover. So what is this maximum range, or you can say the maximum horizontal distance covered by an object, that will be the range. Okay, and at the same time we can also know about what is the maximum height, that is the h max. Okay, what is the maximum height that a projectile will cover. Okay, moreover, we are also interested to know that how much time, for how much period it will be in the flight. Okay, that is something called as time of flight. Okay, so we can say we are also interested in knowing time of flight. Okay, now before solving or before studying anything, I will just give you some simple clues. Okay, that what we need to do, how we can start it. Okay, so see, what we have is some simple tools. We are going to resolve this two-dimensional motion along, means motion in x biplane, okay, along the x and y. So the first task is to resolve the motion in x plane to x direction and y direction. And then we have a second task. What is the second task? Use simple three equations of motion. Three simple equations of motion. Okay. So let's start with the first motion along x. So along x, and similarly along y. Now what information do we have along y? When we resolve this initial velocity into two parts, the horizontal direction and the vertical direction. Since the angle is with the horizon, okay, so that will be the u cos theta. And similarly, the vertical component will be u sine theta. So simple. Now we can say that this velocity along the x direction, okay, the initial velocity, you can say ux, initial velocity along x is the u cos theta. Now, is there any acceleration acting? Let's just not talk about air resistance. Just neglect it. Okay. So, is there any other force which is opposing it? And let's just also not talk about friction. I know you must be thinking of friction, so ignore it. Okay. Now, after ignoring the friction, after ignoring air resistance, all these things, is there any other force which is opposing it or which is supporting it? No. Means there is no other acceleration. So, the acceleration along x will be 0. That's what we are saying. Okay. Now, similarly, along y, what will happen? The initial velocity u by u sine theta. Okay. And let's talk about acceleration along y. What is the acceleration along y? Now, for this purpose, you have to understand one thing, so that you do not make mistakes. Now, the thing is that we have taken the upward direction, the y direction, as the positive. Now, if the y direction is positive, and you know the gravity, is it working upward? No. The gravity is working downward. Every time it will try to pull the object downward towards the surface. Okay, so the gravity is something which is acting downward. So the direction of this gravity is downward. So acceleration along y, it is minus g. G stands for acceleration due to gravity, and minus sign indicate that it is in the downward direction. Okay, so ay is minus g. Now we are going to use some simple concepts here, one by one. Okay, and to solve a problem, say if you want to know about the range, or if you want to know about the time period, if you want to know about the maximum height, there are more than one concept with the help of which you can actually deduce the expression. Okay, let's just talk about first time of flight. That what is the time of flight? Okay, in terms of angle, in terms of initial velocity. Okay. Now, yeah. So here we have the first concept. Now, if you see that when the whole journey is completed, okay, the object is again at the ground. Now, since the object is at the ground, so we can see the displacement in y direction, it is 0. Now, if you just think of that displacement in y direction is 0, that means we can write displacement y, okay, we can write it like y, okay, equals to uy into t, okay, plus half ay t square. The second equation of motion. Okay. Now, displacement, the overall displacement is 0. When it will be 0? Just try to fill. Okay. So, uy is u sine theta. Okay. Into t. And plus half. So, half. And we know ay equals to minus g. So, we can write g minus. And then t square. Okay. So, this g t square. Okay. Now, think it. Okay. What we can do? We can take the t common from both, okay, and then we can write 0 equals to u sine theta, okay, minus half of g into t multiplied by e equals to 0. Now, what does this expression tell you? See, it tells that to make this left hand side equals to 0, either the right hand side t should be equals to 0, or this whole value u sine theta minus half g equals to into t should be equals to 0. Now, definitely when time is 0, when you feel time is 0, you can see the object has 0 displacement. So, the second value, this u sine theta minus half into g into t, is indicating that time when the object will be, at the second time it will be having 0 displacement in y direction. Okay. So, definitely this t, the second t, will be corresponding to the time of flight, when the object has reached again to the ground. So, if I place this t, okay, for this, just replace this small t with the capital T, such that the capital T represent time of flight. So, we can say that u sine theta minus half g capital T equals to 0. So, I can write it time of flight equals to 2u sine theta, okay, by g. After some arrangement, you will get to know this formula. That this is the formula, this is the expression of time of flight. Now, I say that there is not just one way to solve a problem. There are many other ways. Okay, and you can get to know about the time of flight in some other way also. There are some other concepts. Okay, what is that concept? Let's just talk about the second concept also, and we will get to know that time of flight is having the same formula again. Okay, what is that concept? Now we are saying, see, now we are saying, let's just divide this whole journey of projectile into two parts. Okay, one is the time when the projectile was moving upward. That we say time of ascent, the total time to move upward. And then the time journey for which the projectile was moving downward, time of descent. So the total time of flight will be equal to time of ascent plus time of descent. And if we can see here, this target will exactly be in between the center. So when the object will be at this height, definitely it will be taking half of the time of flight, some t by 2. Now, which idea we can utilize here to find out the value of t here? Okay, this is capital T. Now we know that when the object will be at maximum height, at this height, the velocity of y component or the velocity in the y direction of this projectile will be 0, because initially we have thrown it with some velocity u sin theta, but because of gravity it was decreasing, and this height was the maximum height till the velocity was there, but reaching here the velocity is 0. Since the velocity is 0, so what we can do? We can see that y velocity is 0. Okay, so we can write it here. With the help of second concept, we can write velocity in y direction. Okay, so vy, okay, minus vy equals to uy plus at. Okay, ay into t, and we know that vy is 0. This vy is 0. Well, and we know the value of vy, it is u sin theta. Okay, we know the value of acceleration minus g. Okay, and we know that this t corresponds to the half of the time of flight. So I can write it here t by 2. Isn't this equation something similar to this one? And if you just arrange it, what you will get? You will get time of flight equals to 2u sin theta by g. Same. Means we have got the value of time of flight with two different concepts at two different points, but somehow we reach the same value. And in short, you can remember it like this. Well, that the time of flight equals to 2 into velocity along y components, that is u sin theta, okay, divided by g. So this is for the day. If you have any doubt, any kind of problem, please feel free to ask. Okay, so I believe that you don't have any doubts. So this is for the day. In the next class, when we will meet again, okay, we will discuss about the maximum height, we will discuss about the range, and then what we will do that by combining the motion along x and motion along y, we will come up with a general expression of motion of a projectile. Okay, so thank you for the day. Bye bye.